All right. So this is a high-level architecture of Kubernetes on-premise setup that I've done. And today, let's deep dive into this. There you go. First step, right? When we were setting Kubernetes, we wanted to send the traffic that is hitting directly to the physical load balancer to the Kubernetes cluster. But we were not able to do it because of the data center restrictions. They cannot send the traffic that is coming, hitting the load balancer directly to the private subnet. So you need to have some sort of a proxy in place. So that is when we wanted HA proxy in place. So as you can see, the initial traffic that you are seeing here, it's physical load balance traffic hitting on the physical load balancer on port 443. And then we are sending that to the internal cluster, the Kubernetes cluster via HA proxy, right? As you can um, see, this is exactly where we are doing SSL termination also, right? The point of doing SSL termination is we cannot send port traffic that is coming on port 443 directly to the microservices inside. That would slow things down. We are doing SSL termination here, uh, breaking the port 443 traffic into port 80 traffic at HA proxy, and we are sending the data to the microservices. So that's the part. So let's talk about Istio. We wanted to do Istio. The reason why we wanted to do Istio is because we wanted to have a better control of monitoring that we have. For example, I have also an example here where Kiali comes with Istio, and this is the sort of graph that you get. Let's say if you have a microservice 1, microservice 2, microservice 3, microservice 4, microservice 5, you get to see a graph like this. Let's say if some one of the service is down, you get a clear visibility of what the service is down, and what is the latency of requests, what is the average latency for the requests that are happening between these two services. You get a I mean, obviously this is a sample of whatever we are showing. This is a demo version. We have a real production version with multiple microservices communicating with each other. Every time we have some support guy view the check the cluster, some issue happens in the cluster, this is the first graph that they look at. They don't have to go through all this grinding. They can visualize this graph. They know exactly which microservice is failing. Sometimes you also get to see the connection between the service and the database. Sometimes you get to see the issues that happen between service to any external monitoring, any external systems. Let's say we have to communicate with some external APIs, right? The communication failures with those APIs are also displayed here. This is a fantastic tool, and this is one of the reasons why we went for Istio. One of the major reasons, not the only reason. um, Again, as I said, a canary deployment, we want to control the deployment. We want to send some percentage of traffic to the new version, and majority of traffic to the older version, so that we can test things. So canary deployment is one one of the reasons why we wanted to do it. By the way, we did this 3.5 years before, so we don't have a clear visibility of gateway API and all that stuff. Therefore, we have to choose to what is already there. Um, our third important option is MTLS traffic. So where we require both service and the client to authenticate with each other, and to have a secure communication between these two microservices. That is one of the reason also we wanted to go with Istio. As you can see, the traffic between V1 and V2 will have a MTLS enabled. So both these are, respect the security of each other. So they have to make sure that they are communicating securely. So that's one of the major reasons why we have Istio in place. Um, that brings down why Istio grid. Then we will talk about control plane and worker nodes. Okay. Um, we have three worker nodes uh, because we are running it in a data center. We don't have unlimited number of servers. We have very limited number of servers, but these servers are really big, not small. It can be 8 core 64, it can be 16 core 128 GB. It's a piece of a system but directly on the physical data center. It gives you a great abstraction, very fast, right? So master nodes are relatively smaller. We have three master nodes, and we have six. piece of a worker nodes where the pods can be scheduled across these services. Uh, as you can see, these are the data layer where you see the worker nodes, and master is the control plane, and obviously the app is sitting here. All right, let's talk about Helm and why no GitOps. Um, if you notice, we planned for GitOps implementation through Argo CD, where we wanted to look at the state of the new version in the Git, and then we wanted to bring the service through GitOps using Argo CD. But the problem is, at data center you'll have so many limitations, so many restrictions, and one of the strange things that happened to us is that the data center does not allow us to access Git. And the reasons that they stated is because they faced multiple security incidents in the past where people got some rubbish code from Git and then they deployed it on their data center. So they do not have access to it. So we had to stick to Helm. And fortunately for us, they uh, do have access to gave us access to our private Docker. Fortunately, we got access to our Docker, so we were able to use our Helm chats to deploy our microservices. Um, but that's the GitOps thing. Um, how do we plan scaling? Is a tricky situation here because we have a fixed number of nodes for master as well as worker. Traditionally, no matter how big it is, you don't really um, uh, get to scale master nodes because our traffic is pretty much predictable. But you cannot say that 100% of the time you can always get a surprise. So we have two modes of scaling available, as you might expect. But the one is vertical scaling, and the second one is the horizontal. Data center guys can give us additional nodes if we are seeing a very high traffic, but uh, they suggested us to go with a vertical scaling uh, so that we do not incur any licensing cost because the physical nodes that are given to us are Linux RHEL nodes, and each node will have its own license. All right, so let's talk about the internal monitoring. This is the most important thing because setup is all about a few days work, but rest of the things are managed by the monitoring. So for internal monitoring, if we have Grafana and Prometheus, this is a standard stack. ELK is what we are using for logging. Kiali, as you can see, is what we are using for our microservice to microservice connectivity. It also gives us the latency between microservice to microservice. It can also show us which version of microservice is running and which is the older version it's running. So you get so many things that it has. The next one is Jaeger. This is the most important thing that we used. I have a sample dashboard here. It's not from our production, um, where you can visualize the graph and see what is the latency of each front end request that you are getting. You can also get to choose a different service. I don't know if this works, but you can also look at what is happening in your traces for each request, what is happening. This was quite useful for us when we wanted to find the slowness issues. Let's say if the user is complaining about any app slowness, um, we used Jaeger to find out what is happening. In most of the cases, it is the database. A database taking a lot of time to do that. Maybe you can just say 10 ms to 100 ms. So you can also specify the minimum duration, maximum duration, and you can look at find traces, and it'll give you the trace. Right now, I don't have any traces. So yeah, this is a fantastic tool. Everyone should know this, right? So we'll stop there for that. About the external monitoring, we have used Uptime Kuma. Uptime Kuma shows you how your app is responding from outside the world. This is a monitoring that you see internally. right? The external monitoring happens from outside, where we have a simple monitoring server in place, and then we monitor the services. So this is the sample dashboard that you can see. You can check, you can check the external services, like what is the status of my physical load balancer, what is the status of my uh, public endpoints that I already have, what is the status of my dashboard service. All these things can be configured here, and just in case if your entire cluster is down and you do not get any alerts from your internal service, you always have an external service to alert you that something is really wrong with your internal services. So we have both this internal and external service to monitor the clusters, just in case if something goes wrong inside the Kubernetes cluster that we are running our monitoring service. All right, so that's about it. I think it's useful. If it is, I think drop me a like. It would really help us.